Hey guys, my name's Jason with Mount Baker Mining and Metals, and we're back on our gold claim today. I'm up here by myself, and my plan is I'm gonna run this truck mill again. I got some different material I wanna run. It's some float from one of the veins here. So we'll get that set up and start running, but first I wanted to take you up and give you a little tour of some of the veins we have and some of the underground workings we got. But I wanted to show you some of the float we're gonna be running first. Here's the material. It's so what float is it's quartz that's broken off the vein, the hard rock, and rolled down the hill. And I just went along and picked this stuff up off the talus. I got a pile here. There's another pile right here, and it's gold vein. It's right from the vein. It's just been weathered out. So this is from a little bit higher grade vein than what we ran last week. So this is what I'm going to be running today, and now we'll go take a look at where it came from and the source. So here's a good spot. I wanted to show you an outcrop of the quartz vein right on the surface. And so here is the white quartz vein. This is about 2 or 2.5 feet wide, and it's bound on either side by the wall rock or the host rock. And how this was formed is there's a magmatic pluton, a big body of magma that was underground or somewhere near. And as that magma cooled, it concentrated a lot of the sulfides, and the gold in particular is what we're interested in. And as it cooled, it became under a lot of pressure, and it shot the water and silica and a lot of those sulfides off into the host rock. And that's why we have a quartz vein with a high concentration of metals in it, bound on either side by rock that's not worth anything. It's just the host rock that the fluid was shot into. And then as that fluid cooled, the quartz and the gold and all the metals precipitated out into the rock and the vein we have here. So that's a real quick kind of basic geology lesson for you. But here's a good example of what the old miners would be looking for, or if you guys are going to go out prospecting, you're looking for these quartz veins, and that's where the concentrations of those precious metals are going to be. All right, guys, so here's another vein on the property, and this one actually has been worked in the past, and right underneath that pillar right here is some old workings right in here that I've actually blocked off so nobody goes in there and gets hurt. But this is, like I said, a separate quartz vein on the property. Here behind me, it's about 5 feet wide, and it averages about 1.5 ounces a ton up here. So that's pretty rich stuff. They went in, and right behind the chain link fence here is an old stope. And what a stope is, it's where they mine out the vein, and it's the cavity that's left once the vein's mined out. And this vein, just like the other vein we looked at, is pretty much vertical dipping. It's straight up and down, and then the strike on this is north-south. And what that means is the strike is kind of the direction the vein points if you're looking top-down on a map. And then the dip is how flat or steep it is. And so this vein actually dips about 85 degrees to the east. But there's another good example of a quartz vein. And as that fluid is injected into the host rock, as we mentioned earlier, and the fluid begins to cool, it's very, very rare. There's exceptions to every rule, right? But it's very rare to have a vein that is uniform grade all the way through. As those fluids start to cool, the gold and the sulfides is some of the last stuff that tends to come out of solution. And so in most quartz veins, this one included, there's actually some really rich bands in the vein, where there's some other sections where the quartz is pretty much barren. So most of the time, you can go in and find some good juicy spots in veins where you can high grade them. And we'll go take a look at another vein here in a second where we've identified some high grade areas, and we're going to come in next year and do a little bulk sampling, hopefully some drilling and blasting. But the vein, depending on the geology and the structure, can run for hundreds of or thousands of feet, and it can pinch or swell in width. Also, not only as the vein cooled, it hydrated itself, but a lot of times there are some structural elements that allows the vein or forces the gold to deposit in one spot and make a really, really high grade area. Those are typically found when the vein is going along and makes a bend, or when the vein intersects a fault or another vein. Pretty much anywhere that you can have a change in pressure, chemistry, or temperature when the vein is depositing, that's where you'll have some really, really high grade rich zones. And so that's why it's so important to do your drilling and your sampling, because what's either on the surface or one drill hole doesn't necessarily mean that, you know, a vein is a really rich all the way through. It could be either hit the really good stuff, or you've missed the really good stuff, and with further exploration you might find it. All right, guys, so now we're actually in a stope as well, and this is more of a flat-lying vein, and so I can actually get around and walk on the footwall of this stope and go down, and we can take a look at the vein and some of the faces that the old miners left. But in any stope, there's two walls. There's the foot wall, which is the one that you walk on, and the hanging wall, which is named after the miners hanging their lanterns on or something. And so I'm going to walk along here. The vein in this stope got as thick as 7 or 8 feet, but where the miners left it off and some of the faces we're going to look at, it's probably closer to 2 to 3, almost to 4 feet thick. But we'll take a walk down here, and I'll show you some of the old stopes and the pillars that are essentially holding the wall, the hanging wall up over my head, and we'll go take a look at some of those high-grade areas where we're going to focus on next year. All right, so let's see how we do here with my light, lighten up the area here, because it's going to get pretty dark in here, but... So you can see down, there's some of the pillars. There's a pillar right there. And then the stope, the empty space where they took out the vein. Here's another big pillar. And this pillar is all still ore. It's quartz they left. They had to leave it, so the hanging wall didn't come in on them. But that is kind of what a stope looks like for people who haven't been in mines before. And because they left the pillars, or you could actually determine the thickness of the vein by what they took out. And right in here, you know, it's actually pretty, it's hard to tell in the video, but it's pretty thick. That pillar right there from the quartz goes down somewhere in there all the way to the hanging wall is somewhere in the 7-foot thick range. But it's essentially just like a big cave in here. And we'll go do a little more exploring and see what we can see. A lot of these old piles here that you'll see around in the stope is waste rock that they didn't want to hand muck out. And so they just had someone, you know, probably a young kid, stacking waste all day long. Here's the hanging wall again, and then there's a big chunk right there. There's another big chunk right there. Those came off of this hanging wall sometime in the past. There's some more chunks. So there's a section here in the mine that's probably not very stable, and you can see, looking up at the hanging wall here, this piece. See that big crack right there? All the way along there, that piece is just barely hanging on. So this really points out some of the dangers of going in old abandoned mines. It's just not a very safe place to be, and you know, there's a lot of safety concerns, and if you go work underground, you actually have to take quite a long, rigorous class for safety, just to be eligible to go underground. So we'll work our way over here. And when they were working in this mine, it was, it actually worked up until the 20s. And at the beginning, it was all single jack and double jack, which is by hand, one guy holding a piece of steel, drill steel, and the other guy hitting it with a hammer. And that's how they would drill their holes to blast. And then in the teens and 20s, they ended up getting some air power up here, probably a compressor, and they ended up using jack legs. But here's actually quite a beautiful pile of stacked rocks there. The Romans would be proud. But here is, this piece here is a wooden stull, is what that's called, and that's just a big block of wood that they wedged between the footwall and the hanging wall to keep this big piece from falling down when they were working. So that's probably been there about 100 years. And then looking up over here, there's another one, and there's another one. So they were pretty concerned about some of these big pieces coming off the hanging wall. So they stole them up for support. When, and they did that when the pillars weren't enough, to keep it safe in here for them. And so whenever I'm in old mines or old stopes, my rule is never touch any wood. Don't touch anything holding the ceiling up. Don't get near it. Don't cough on it. Stuff like that. And then here is an ore transfer tunnel. There's the rail. And they would run ore carts back and forth. And they'd muck out the material and send it down to the mill. And so looking up to the stope we just came out of here, they'd be up there working, drilling and blasting. And then someone would bring probably hand muck the stuff down the stope here and shovel it into ore cars that would be here. And then they'd take them down the rail and outside to the mill. Watch your head. But we're walking along our rail here. And this is a section of the vein that's actually pretty interesting. I don't know if you can see it from here. We'll get a look up closer. There's the working face. So there's the vein. And right in here, this vein is flat lying. It goes all the way across there. That's all vein that the light's on. And it's in here perfectly flat, where the stope that we were just walking down is dipping to the south about 25 degrees. And as I mentioned earlier, whenever you have a bend in the vein or a spot where something changes, it's typically really high grade. And we've identified this area of the vein, this flat-lying area, as a really high-grade zone. So let's go up and take a look here at the vein. And we figure right here, here's an old blast hole that they did. And I've been down here taking samples and looking around. And this vein is, probably 3 or 3.5 feet thick. You can see it's quartz, and then it goes into the hanging wall up there. But some of the assays we have, there's probably 20 or 25 feet of strike here along this vein, 2.5 to 4 feet width. And my assays have been coming back between 2 and 3 ounces a ton here. So our hope is to get some equipment in here, do a bulk sample, get in here and drill and blast, probably do a little stope round, maybe get 10 ton, 15 ton on the ground, and hand muck it out next season, run it through our system, and see if we can get enough gold to make it worthwhile to actually develop this mine from the outside, so you don't have to be in here in the old workings. But that's kind of the strategy we have for next year. And this year we're testing out the equipment. We're doing some sampling. We're cleaning up what the old miners missed. And even before we start drilling and blasting, one of the first things I'm going to come in here next year is there's a ton of quartz that didn't get mucked. All this stuff laying on the floor, even this stuff all right here. This is a big pile of good ore that never got mucked out. And so there may be 2, 3, 4 tons of stuff here that may have, an ounce or two. It's probably been diluted a little bit by some waste when they were shooting. But it's just laying here. All you got to do is scoop it up. There's no drilling, no blasting, no screwing around. And so that's kind of our strategy for developing or reopening this old mine is start slow, start small, get the stuff the miners missed, get the stuff outside, get the float, and then come in, identify some high-grade areas, muck those out because you don't have to do any drilling and blasting, and then come in and safely do some bulk samples with some equipment and get that mucked out, do your sampling, and then if you can prove to yourself that it's a profitable mine, come in and rehab the old workings or develop some new workings so that you can get some mechanized equipment in here and go mining. Well, sometimes you just got to do hard work in the rain. So right now I'm going to load these small piles of quartz that I have, all this quartz float I collected, onto the back of the truck, and then we'll drive down and get our system set up, plug in the sluice and get the pump going, and we'll start processing our float. All right, guys, so we're all set up. We got our ore on the back of the truck there, our literal pot of gold. And it took me about 15 minutes to set it by myself. So I put the sluice on and I got the pump in. I left the generator right there on the truck because I can't lift it off by myself. So it literally took me about 15 minutes to get set up. And now I'm going to start the jaw crusher and I'll crush as much ore as I can into buckets. I think I got about 12 buckets worth. So I'll crush as much as I can, then I'll turn the jaw crusher off, and then I'll start running the hammer mill. Okay, I crushed 10 buckets worth here, and I've weighed a couple of them, and they average about 70 pounds a piece. Some are a little over 75, some are a little under at 65. But we have figured about 700 pounds here. I'm going to start up the hammer mill and get the pump going, and we'll run our stuff down the sluice box and into that bag. And that bag is just to collect the tailings. I'm probably going to come up next year and bring the bag down. There's probably still enough gold in there that you want to save them. And using those super sacks, it's really great because they can contain it all. It's easy to move, and the water leaks out of them. All right, so we just finished up. I ran a total of 18 buckets, and it took me exactly 2 hours to from setup to tear down. So I've got everything pretty much put away now. We'll go over and take a look at the sluice here. and see what we can see there. But at 70 pounds a bucket, I think that's right around 1,250 pounds in 2 hours. I was screwing around with the hammer mill a little bit. I actually learned something. It kept getting starved for gas and dying. I did it 2 or 3 times, and I realized I didn't have the vent open in the gas tank. So that cost me about 15 or 20 minutes, but I think that's pretty good. I mean, for one guy to come out and in a couple hours set up, run, you know, half to 3/4 of a ton of material, and then tear down and get his gold in the sample is pretty darn good. But let's go take a look at the sluice box, and we'll see if we got any gold showing in behind the diamonds. All right, so a little bit of reference here. There's the hammer mill. Here's the discharge chute, and it comes right down here onto the diamonds. And if you look real close, right in here and along there, let's see if I can get this to focus, even up close. But right, where's my finger? Right there is full of gold. There's some gold here. It's kind of all up along the top here. And then as you come down, I don't see a whole lot. There's some over here. Where's my finger? There it is. There's a little piece. Let's see if I can, come on, focus. So there's some gold. There's some gold up here. There's a little bit, it looks like, over here along this side. Oh, there we go. So there's some gold down there. But as you come down the sluice, and I know you guys probably won't be able to see this, but as you come down the sluice, you don't see any gold at all behind the diamonds. It's just black sand. It's actually that pyrrhotite sulfide that we have in our ore. But yeah, so I think the sluice is doing a pretty darn good job. Like I mentioned on some previous videos, the sluice gets about 80% of what the shaker table can get, somewhere in that range. So we're going to save this super sack of tailings and probably end up bringing it down and reprocessing on the shaker table. Oh, come on. There we go. But yeah, that thing's probably about 2/3 full to 3/4 full now. So let me pull off those 2 bolts. I'll get this sluice washed out in a bucket, and then as much fun it is to stand out here in the rain, I'm actually going to just put it in a bucket, and then I'll bring it down to the shop and we'll pan it out there. And I may run it on the shaker table and get it cleaned up, and then we'll smelt it down and see how much gold we recovered. Okay, we're down here. We got our bucket of cons. I'm just going to pan these out here in this pan and catch pan. So far into this project, I have 3 hours. I've got an hour to pick up the float. I've got 2 hours to run the material. And then here I'll have about another half an hour screwing around, panning and getting the gold cleaned up. And I've used probably about 1.5 gallons of gasoline. So that gives you guys some idea of the time we got in it. But let's pan out our gold and see how much we got. All right, I'm probably going to do about 2 or maybe even 3 pans here. The materials, I got enough material that it's going to take a little bit to get it all panned down. I was thinking about using my 4x8 shaker table to clean these up a little bit, but it's really windy and pretty nasty out today, so I'll just do a little bit extra work and pan them down. But the whole idea here, just like with the table, is get it all fluid, and the gold sinks right down through all the sand right to the bottom of the pan, and then you can just slowly and gently wash the quartz off the top. You can see all the white quartz coming off. It's starting to reveal the darker colored sulfides underneath. And then you just repeat this process until you're down to the last little bit where the gold should be. So I'll get this pan down. You guys don't need to watch all of this, and then we'll take a look at the results. All right, well, I panned the whole bucket down. I've got a little bit of the sulfides here we're working through. So I'm going to get these panned down, and then we'll take a look at our gold. But there's been a pretty healthy gold line right at the base of the black sand there. I got it covered now. But I'm hoping there's going to be some pretty good gold in here. All right, guys, so here is our gold. There's still quite a bit of black sand in there, but I got impatient and wanted to take a look. And unlike a previous video I did here a week or two ago, this gold is a lot coarser. It's a lot bigger size pieces, and hopefully that means we got quite a bit more weight here. So let's see if we can work on getting this melted down into a little button, and we'll see how much weight we have here. Okay, guys, we got our cons here, and this is a little cast iron griddle I picked up at like Goodwill or Salvation Army or something. And I'm just going to wash all of our cons down onto this frying pan. I'm just going to dry them out. And I haven't done a gold smelting video in a long time. So I am going to smelt down all this gold into a button. And then we can cupel it, depending on the impurities. So, I've got all our stuff washed into our pan. I'm going to shake that around a little bit, get it all spread out. Just going to pour the bulk of the water back in here. And there we go. We got our concentrates in there. Now I'm going to put it over our furnace, and I'm going to just dry it out. We'll probably roast it a little bit, but that's not really the intent. And then we'll mix up a flux recipe and smelt this down, pour it into our cone mold, and we should have a nice, pretty gold button. All right, guys, here's our cooled off slag in the cone mold. We'll knock her out. And hopefully right here on the tip of the cone, we got a little button. Let me get a little hammer, we'll knock it out of there. So there's our little button. It's still got some impurities. It's still pretty silver colored, so we'll have to cupel it with some lead and get those impurities out of there. But there's our initial nice, cleanly smelted metallic button. Right, guys, here's our little button. We'll get a weight on her before we Q-pel it. Looks like it's right about 10.5 grams. So now we can figure out how much impurities we remove by weighing the gold button when it's refined. And here's our little magnesia Q-pel we're going to use. I'm going to put our gold bead in there. I'm going to add a very little bit of lead, maybe 5 or 10 grams. We'll heat it up to about 1900 degrees. The lead will oxidize and start being absorbed by the Q-pel, and it will carry any impurities with it, just leaving the precious metals, the gold, silver, and any platinum, palladium, stuff like that that won't oxidize in our gold button. All right, our furnace is heating up here. Here's our Q-pel, gold button, and lead. Furnace is getting warmed up, so I'll place that in there. We'll check back in it here once it's molten and oxidizing. All right, guys, here's our button. We got her all cooled down. This one actually turned out really, really nice. So let's get her weighed here. Oh, we lost quite a bit, actually. I'm surprised we lost that much. So we lost, I don't know, what's that, about 20% of the weight. So we had quite a bit of impurities in there, but now we got it just down to the gold and silver. And at, what's that, almost 9 grams? 9 grams from about 2/3 of ore. That stuff was probably running about, I don't know, 1/3 of an ounce, maybe a little bit more, a ton. So that was better float than the first video I did with the truck mill. And you can check that out on our channel. But I hope you guys enjoyed the video. Thanks for watching. And if you have any questions or comments, you can find our contact information in the description below. So thanks again, and we'll see you on the next one.